Novdec 2025 Core Mathematics Paper 2, Question 10. Let's begin with the A. A farmer plans to use 25 meters of fencing to enclose a rectangular field of area 63 meters squared. Three sides of the field need fencing because part of the existing wall will be used for one of the longer sides. Find the dimensions of the field. So we have a rectangular field. So because it's a rectangular field, it will have two dimensions. The longer side is the length. I'm representing that with capital L. And the shortest side is the width, represented as W. Now the area of the field is given as 63 meters squared. We know that the area of a rectangle is given by the length multiplied by the width. So when you multiply the length and the width, this should be equal to the area of the rectangle, which is given as 63 meters squared. So this is our first equation. Now, this farmer plans to use 25 meters of the fencing material to fence around the rectangular field. But in his case, he is only going to consider three sides. Why is he considering only three sides? Because we are told that part of the existing wall will be used for one of the longest sides. So one of the longest side has already been occupied by a wall. So because it has already been occupied by a wall, that portion will not be fenced. So let's represent this longer side as the existing wall. So that is the existing wall. So that is the wall. So with this, we have only three sides of the field remaining. And we know that the total distance around the rectangular field is the perimeter. So for this particular wall, the perimeter, in other case, the distance around this field will be this width plus this length plus this width. And this is simplified as L plus 2W. So that is the expression for the perimeter of this particular wall. So L plus 2W must be equal to the available fencing material, which is 25 meters. So this is our second equation. Now our goal here is to find the dimensions of the field. In other words, the length and the width. So we need to solve this equation simultaneously. So to do that, I think we can do that by using the substitution method. So let's make either L or W the subject in equation 1. So let's make L the subject in equation 1. So when we make L the subject in equation 1, we have L times W is equal to 63. So we divide both sides by W. So W will cancel out, leaving L is equal to 63 on W. So we have L equal to 63 on W. So let's make this our third equation. Now the next step is that we need to substitute equation 3 into equation 2. So we put equation 3 into equation 2. So meaning that anywhere we see L, we substitute 63 on W. So let's look at equation 2. In place of L, we have 63 on W. plus 2W is equal to 25. So we need to simplify this by multiplying each term by the LCM. So in this case, the LCM here is W. So we are going to multiply each term by W. So we have W multiplying the first term, which is 63 on W, then plus the second term multiplied by W, so multiplying 2W, and this must be equal to the third term also multiplied by W, so 25. So we see that W and W will cancel out. We are left with 63. And then W multiplied by 2W, we have 2W squared, and this must be equal to 25W. So we see that we are getting a quadratic equation. So let's rearrange to get our quadratic equation. So we have 2W squared minus 25W plus 63 is equal to 0. So at this point, we can factorize. We know the coefficient of W squared as 2, and the constant is 63. So when you multiply the 2 multiplied by 63, that is 126. So let's find factors of 126, whose sum will give us minus 25. So that is minus 18 minus 7. So we have 2W squared minus 18W minus 7W plus 63 is equal to 0. So let's group them. We group this, then we group this. So let's factorize each bracket. So what is the common factor here? Common factor here is 2W. So we are left with W minus 9. Then the common factor here is 7. So we are left with W minus 9, and this must be equal to 0. So we have W minus 9, W minus 9. So we select 1. Then the outside factors, we have 2W minus 7, and this must be equal to 0. So now we can solve for W. Let's pick the first one. W minus 9 is equal to 0. So the first value of W is positive 9. Now the second one, we have 2W minus 7 equal to 0. So 2W is equal to 7. Now when you divide both sides by 2, 2 will cancel out. We have second value of W as 7 on 2. 7 on 2 is 3.5. Now that we have the values of W, we need the values of L. So how do we do that? So we are going to substitute the values of W into any of the equations. So I'm picking equation 2. So now let's put W is equal to 9 into, okay, so let me use a different ink. So we put W is equal to 9 into equation 2. So equation 2, this is equation 2. Anywhere we see W, we substitute 9 there. So we have L plus 2 multiplying 9 is equal to 25. So we have L plus 2 times 9, that is 18. This must be equal to 25. So L is equal to 25 minus 18. So see that L is 7. So when W was 9, L gave us 7. Next, when W is 3.5, when W is 3.5, what happens? So the same approach, we are going to put W is equal to the second value of W, 3.5, into equation 2. So anywhere we see W, we substitute 3.5 in equation 2. So we have L plus 2 multiplying W. So this time W is 3.5 and this must be equal to 25. So we have L plus 2 times 3.5, we have 7, and this must be equal to 25. So L will be equal to 25 minus 7. And what is 25 minus 7? So L is 18. So for the second instance, we saw that when when W was 3.5, we had L as 18. So what are the possible values of the length and the width? So you can say that the dimensions of the field are the first one, the length being equal to 7 meters and the width equal to 9 meters. That is one instance. Or you can also have the length being equal to 18 meters and the width being equal to 3.5 meters. Question 10b. The angle of depression of a point P on the ground from the top tier of a building is 33.6 degrees. If the distance from P to the foot of the building is 75 meters, we have to calculate correct to the nearest meter the height of the building. So first of all, we need our level ground because we know that the building is on the level ground. So there is our level ground. We have our building drawn in blue line. Now we know that the building and the level ground will always meet at an angle of 90 degrees. So there is a 90 degrees angle. And then there is a point P on the ground. So there is the point. I'm naming it point P. Now the top of the building is labeled as T. So we are labeling the top of the building here as T. And then the foot of the building. There is the foot of the building. I'm naming the foot of the building as F. So now let's measure the angle of depression. So there is the horizontal line of sight. We know that the angle below the horizontal line of sight is the angle of depression. So we want the angle of depression of the point P from the top of the building T. So the angle below the horizontal line of sight is the angle of depression. So the angle here, this angle is the angle of depression. We are told it measures 33.6 degrees. So what is the relationship between the angle of depression and this angle? So these two angles are alternating. We know that alternating angles are angles from the alphabet Z. And we also know that alternating angles are equal. So this angle here also measures 33.6 degrees. So that is the angle of depression. So we have our right angle triangle. There's our right angle triangle. And remember, we were told that the distance from P, so the distance from P to the foot of the building measures 75 meters. So the distance from the foot of a building to P, 75 meters. So we are looking for the height of the building, that is line TF. I'm representing the height of the building as H. So line TF is represented as H. So since we have our right angle triangle, the first thing we do is that let's try to identify the size of the right angle triangle. We know that the longest side is the hypotenuse. So this is our hypotenuse. The side facing the acute angle, these are opposite. And then the remaining side, that is line FP, becomes adjacent. So we are looking for H. So let's refer from SOHCAHTOA. SOHCAHTOA. Again, from the right angle triangle, we are looking for H, which is the opposite. We know the length of the adjacent. So among SOHCAHTOA, which of them has opposite and adjacent at the same time? The opposite and adjacent, that is TOA. And we know that TOA says that the tan of the acute angle, which is theta, should be equal to the length of the opposite divided by the length of the adjacent. So we can start with our calculation. So from the right angle triangle, so from triangle, we are naming the triangle FTP. FTP. From this triangle, we know that the tan of the acute angle, so the acute angle here is 33.6, is equal to the length of the opposite line TF. It has been represented as H divided by the adjacent 75. So we have tan 33.6 being equal to H on 75. So tan 33.6 is the same as tan 33.6 on 1. So at this point, we can cross multiply. We can cross multiply. So what happens? Let me get a space here. So we have 75 multiplying times 33.6. So this gives 75 times 33.6, and this must be equal to 1 multiplying h. So that is h. So 75. Okay, so let's compute this. 75 times 33.6. So that is 49.8299. So h is 49.8299. Remember, we have to correct to the nearest meter the height of the building. So to the nearest meter, we have h as, so I think that is 50. You can round 49 up, so that is 50 uh, meters. 50 meters. So hence the height of the building is 50 meters.